So after this very, very engaging talk that we had, we're going to move on to our next panel, which it's actually a set of discussions, slightly different format of panel that we have. It's on the topic, the role of cloud computing and hardware innovation in AI. And it's clear to all of us here, we wouldn't have such powerful AI without the breakthrough computing innovations we've had in the recent years. And cloud is that technology that makes that power accessible to all of us. It democratizes that access, it makes it affordable, and it helps reach in this technology, the power of this technology in the hands of the last mile, the last person. So it's my pleasure to invite our experts now to share their thoughts one by one, to share their insights on this particular topic. First of all, ladies and gentlemen, I want to invite our host for this session, Mr. Arvind Tiwary. So, Arvind is an alum of IIT Kanpur, of IIM Ahmedabad and Wharton, has over 3 decades of experience across financial services and information technology. He's now the CEO of SangEnnovate and has previously built successful global software companies. So with this, I would like us to give him a warm welcome again, Mr. Arvind Tiwary. Yeah, so the first member we want to bring on stage is a brilliant AI chip expert. He holds a PhD in computer science from IIT Kharagpur, holds 14 patents and has over 27 years of experience at top tech companies like AMD, IBM, HP, Motorola and Wipro. He's a senior principal engineer at Intel Habana Lab, where his area of focus is the compiler optimizations for AI chips. Please join me in welcoming Dr. Dibyendu Das. Next up, I'd like to invite a digital innovation expert and the senior vice president and global lead at Hexaware Interactive Digital Experience arm of Hexaware Technologies. He has over 20 years of holding key leadership roles at Publicis Sapient, Gvox and other giants. He's known for developing disruptive yet customer-focused products across industries, from automotive to healthcare. Let's give a warm welcome to Mr. Gourishanker. We're getting the mic set up. You'll see him very soon. And then our third member of this session is Madhuri Susarla. I'd like to call upon Madhuri on the stage. She's an alum of IIT Madras and the head of partner technology strategy in India at AWS. She's an Amazon bar raiser and has an expertise in large-scale cloud transformations, technology incubations, and cloud architectures. Please join your hands again for welcoming Madhuri Susarla. I'd like to now hand over the stage to you, Arvind. Please go on.
Thanks. Thank you for being here. And it's a Saturday, and we will try to keep you engaged. This session is a mixture of 2 separate sessions we are planning. One was around AI hardware, the NVIDIA GPU, inference, etc. And the other one was around cloud. And for various reasons, some people were not able to make it. We have merged them together. So we are covering a range of topics, but the broad idea is that cloud is a common way to try new things. You can get hardware, you can scale up, scale out, very standardized, very proven, very cost effective. But AI is a problem because most of the new AI, apart from the inference, etc., which Professor Nathan showed, which can run on CPUs, etc., most of the new AI uses GPUs. And NVIDIA GPU is a cluster choke point for a lot of things. You may be surprised that it's less than 5% of TSMC's business. But the growth in this demand is enormous. If you have watched, NVIDIA has demonstrated 1-year revenue growth more than 6 years of its last 6 years. The demand is very high, and cloud providers have an issue of how to plan for a demand which is far higher than in plan. So we will discuss that. I'll ask Professor Dibyendu to present a little bit about a core part of interoperable technology, which is around compiler.
Thank you. I did a click off maybe for the slides.
The slides
We need slides up and a click of the slides.
And you need to.
I'll be going through something of the software stack that kind of drives modern. Can you get into the presentation mode? Yeah, thank you. Okay, so I'll talk very briefly about, because we have about 10 minutes per speaker. Oh. Okay, good. So very briefly about, you guys are aware of AI. Obviously, people are writing models. You hear about models, and then finally you just hear about performance and all the things. And there are a lot of things happening in between, from the time you write your model to how your model runs on the hardware. And there a lot of traditional stuff is happening, most of which is compiler technology and distributed computing and high performance computing. So I'll just touch upon the compiler aspect of it, not the others, and our other esteemed panelist members will be talking about the cloud aspect. So if you are writing your models today, let's say in PyTorch or TensorFlow or JAX, and you want to run it on a plethora of hardware, like if you are a service provider, if you produce something, you want them to run on your CPUs, GPUs, other hardware accelerators. So as I said, a compiler is the main story out there. And the compilers that we're going to talk about a bit are having reusable components which can be used across vendors. These are open source, and they also have powerful target-specific code generators. Oh, okay. Okay, so it's a bit of a dense slide for many of you guys, but let's look at it, what is happening. So from the top, when you have a PyTorch, TensorFlow, or a JAX model, what the compiler or the front end of the compiler does is to make it look like a computation or a data flow graph. That is, you have your deep learning operators which are doing your matrix multiply vector operations, and then you have edges running between them, which is transferring the net tensors or the matrices between this data. And after that, we have a lot of these what are called as target independent optimization. We do algebraic optimizations. We do what are called as fusion. That is, you don't go to the memory again and again. You fuse operators so that you run it once. We do a lot of memory optimizations and so on. And then once these high-level optimizations are done, we go to the low-level, what we call as low-level code generation, where you can generate your code for your particular machine, maybe Intel CPU with special AI hardware, Intel Gaudi with special AI hardware, NVIDIA with GPU cores, Google TPUs, and we also have Trainium and Inference Chip from AWS and so on. So if you look at the AI hardwares today, and this is not the full set, as I said, there are other hardwares around that, but if you look at this set, today's, let's say if you look at Intel's, NVIDIA's, and Google's, and even Trainium and Inference, all of them have two special characteristics which you will find in all of these hardware. They have what are called as tensor processing cores or matrix multiply units, and surrounding that they have what are called as vector processing cores, which also operate on the non-matrix multiply convolution kind of operation. So these are two crucial parts of any hardware accelerator or the GPUs. GPUs are traditionally built for HPC, so they didn't have a tensor core or a matrix multiply engine. The tensor cores only came later. But, like Intel Gaudi and the Google TPU, they had, because they were built for AI, from day one, they had this matrix multiply engine and the tensor processing cores. The difference is, in the GPUs, the tensor processing cores are much smaller in size, operating on much smaller tensors compared to what happens in the other engines. Okay, so if you look at the architecture for a real compiler today, you are already familiar with PyTorch. PyTorch 1.x was not really a compiler, it was an interpreter. PyTorch 2.x has become a real compiler. So what it does is, it has a front end called Dynamo, which converts your PyTorch model to what is called as the FX graph, which is like the computation graph that I told you earlier. And then it goes through, we call it the back end, but let's say the middle end, where it will do the operator fusion, etc. And that is called the torch inductor. The torch inductor is a very, very important part of PyTorch today, and without the torch inductor, you may lose 2x, 3x, 4x performance on the PyTorch model. So if you guys are already employing models, please try to use the pytorch.compile. It is definitely going to give you performance, no matter on what hardware you are running your systems. And then at the back, you have the kernels or the actual small operators which are running. They can be written using Triton or C++ OpenMP or CUDA or whatever it is. So PyTorch 2.x plus Triton. Triton is a new language similar to OpenCL, CUDA, and DPC++. And what it helps is you can write much simpler kernels than CUDA and get the same performance as CUDA today. And Triton has come out from OpenAI, but now almost every vendor is trying to generate code from the top to the Triton. And once you generate Triton, the backend can be patched to Triton to generate, good code for you. So the other part that I have to talk about is, we talked about PyTorch. It's still kind of, I'll not say vendor specific, but Meta has developed it, is still open source. But there is another kind of movement in industry. People, you may know that, you know that modern compilers, which are like C, C++, and Java, heavily rely on this open source compiler-based system called LLVM. So you have all these front ends which are generating LLVM, which is called LLVM IR. It's an intermediate format, and on that you do a lot of optimizations, and finally you'll generate machine code for your hardware. And the same idea is being now taken to deep learning compilers. So under LLVM, there's an effort called MLIR. MLIR, some people say it's called machine learning IR, some people call it middle level IR, whatever it is. So this IR is the new IR which is driving the adoption of open source for the deep learning compiler and the deep learning software stack. And how it's happening is this, that you see your DL model, it can be written in TensorFlow, PyTorch, or even the new Mojo language that Chris Latner and his team is defining at Modular. And you get your graph, and from your graph, it becomes a real compiler in the sense of LLVM. You get into something called an MLIR, where you can define your program in that graph model, and then you do all your optimizations, you generate LLVM code, and finally you generate your target ISA. And whatever you are seeing in the dotted box, it's all happening open source, in the open. All the companies are putting the effort for it. If you still want to do something on your own, the licenses like Apache and MIT are generous enough that you can still pull from the open source and still put your own stuff and go ahead and do things. So, because we have a very short time, I just wanted to throw some terms at you so that you know whenever you're discussing what are the stack we are talking about. So whatever you are seeing today is just not the hardware. Hardware is providing definitely a lot of your boost. The models are providing a lot of your boost. But in between is this software stack relying almost entirely a lot on compilers and the optimization that the compilers do on better code generation to give you 2x, 4x, 5x, 6x performance improvement over multiple number of years. And that's not a small amount. We know about cases where, like I said, that if you don't do PyTorch.compile, you are going to see lower performance for your models. So these are all, as I said, in open source. These are the directories. If you are not having your own hardware, but still you want to improve performance for your models, you have specific cases that you want to handle, you can still, get involved, pull this, create your own stack in a way, and run it. It need not necessarily be the stack given to you by OpenAI or Meta or someone else. Today, actually, you can build your own stack. And most of it can be driven by open source. I'm not saying that it's going to be easy, but there is a great possibility of doing that. And the hardwares that we have today, because of this fast, rapid output coming out from the software, you can target newer hardwares, especially if you are working at the edge or doing FPGAs and things like that. You can use and modify this kind of softwares for your use cases very quickly. So that's a very short introduction, and thanks, Arvind.
Thanks. For those of you, LLVM community is pretty large in Bangalore. There are work group meetings. I would encourage you to add. It's also part of something called domain-specific languages, which will hit LLMs very fast. One question. Where can somebody use Intel's Gaudi chips? Any cloud server available?
Yeah, today, good question. So, Intel's Gaudi got, delivered to AWS last year, and the earlier version of Gaudi, Gaudi 1, was already available from AWS. But today, Intel now has launched, just last month, the Intel Developer Cloud, on which the latest version of Gaudi, Gaudi 2, which is the Intel main AI accelerator, is available, and people can, apply for and get access to the cloud and work on that. Thank you.
For those of you, most of my developers, we run a large LLM. They think Gaudi is a better play for inference, but we'll come back to that question later. Thanks.
Thank you. Thank you.
Gourishanker. I will invite you to present, and I will give you 2 minutes warning before we reach time limit. We are good for time right now. Go ahead. Sorry. Is wide up.
Click up. Next one. Yeah. This next. The one for go forward.
Great presentation, Dibyendu. Am I audible? Right. He did stick to his time slot. I'll try and do so as well. Good afternoon, everyone. I'm Gourishanker, and I'm excited to be here at Pivot 23. Right. While my presentation comes up, basically, in an era where data is the new currency, the coming together of cloud computing and AI promises to be the game changer for businesses worldwide. So the next 10 minutes, we'll talk about these two transformational technologies and how they are opening up new avenues for innovation, efficiency, and growth. Okay, so when you look at cloud computing, it was basically a paradigm that provides on-demand access to shared pool of configurable computing resources over the internet. The progress has been over 3 different waves. The first wave was infrastructure as a service, which basically provided unprecedented scalability, flexibility, and accessibility, right? And the focus was essentially on shift from capital-intensive IT investment to operational expense. Then came wave 2, which was platform as a service. This essentially offered a comprehensive platform that not only simplified application dev and deployment, but also fostered innovation by actually shortening the app dev lifecycle altogether, right? And the shift was actually from managing infrastructure to delivering value through application dev and deployment. The third wave is software as a service, which is characterized by advanced technologies such as AI, such as machine learning and serverless computing. Right? Basically, cloud computing provides the foundation for data-intensive and computationally heavy AI applications. With this, I would like to get a little conceited and talk about Hexaware and what we are doing at Hexaware. At Hexaware, we have a bold vision for AI-first world. We believe that the next-gen customer experiences are going to be driven by AI. So essentially, we're moving from mobile first, digital first, to now AI first. At Hexaware, we work with our clients and leverage cloud computing and AI to create exponential value for our customers. And how do we do it? This is our framework. Basically, you have to start with cloud enablement and modernization. Hexaware has a platform called Amaze. And I'm always thrilled to talk about Amaze, right? Because Amaze is not just a platform, right? Amaze is a patented solution. Amaze is essentially demonstrates Hexaware's commitment to innovation, Hexaware's commitment to pushing the boundaries of cloud infrastructure. So for Amaze, we have Amaze for infra, we have Amaze for apps, we have Amaze for data and AI, and Amaze for QA. Amaze for infra essentially does a quick, non-intrusive lift, tweak, and shift of migration of infra. It also has a assisted self-service. It's available on the marketplace, and I would encourage you guys to go have a look at it. Right? Amaze for applications basically helps modernize mission-critical core applications. It supports containers and provides PaaS capabilities. Amaze for data and AI basically helps with complete data warehouse ecosystem migration, includes data store, pipelines, and visualizations thereof. And Amaze for QA provides the end-to-end platform, basically helps with cloud testing and validation. Okay, once you have your cloud enabled and modernized, that is when we have the AI framework coming in. But when you look at Amaze, it's not just that we are proud of it. If you look at basically the Gartner Magic Quadrant for public cloud transformation services, Hexaware is a visionary. Amaze has been recognized and ranked in many of these surveys, right? We have used Amaze extensively across 6,000 plus applications for 40 plus Fortune 500 customers, 400 plus applications have been transformed for 20 plus Fortune 500 customers, and we have a great pipeline, 800 plus applications for 30 plus global customers. If you look at the logos, some of the biggest ones are there which are using Amaze, right? That essentially validates the value prop that we are providing there. Okay, getting back to this approach. So basically our AI framework starts with a consultative approach called Decode.ai. Decode has its roots in design thinking. So it helps break down silos within the organizations because you can unlock value through AI by looking at a problem holistically. Okay, and so that is what design thinking helps us with. It starts with market research. It starts with connecting with the business and IT stakeholders, and that helps us understand the challenges, right? And then you get into the empathize and define phases where we look at defining the problem along with our design thinking experts, along with our Gen AI experts, right? And then comes the ideate and prioritize. So that's where these experts on cloud computing AI basically provide solutions to these use cases, looking at where friction is, how do you remove this friction, right? And then you prioritize based on tech feasibility, business viability, and most importantly, right, human desirability. Okay. Once you have this prioritized list of use cases that you're going to work on, you need to validate the risks and assumptions for all of this. We also come up with an execution plan. And that is essentially where Encode AI comes in. Encode AI is your first step to AI implementation. It starts with identifying data sources, basically looking at readiness. From a data perspective, data accessibility, your quality of data, your relevance of data, that is looked at, but that's not all that is from a readiness perspective. You also need to look at skills, availability of skills. You need to look at infra, you need to look at the partnerships that you have, right? And basically, we do the gap analysis. We work with our clients to make sure that they are ready before we move on to the next step. The next step is what we call as active experimentation, which is essentially starting small, doing POCs, validating your hypothesis, testing it, and once you've done that, it's important that you scale really fast. So that is what comes from active scaling, which is what is here, pilot to production, right? But your AI journey doesn't end there. You need to make sure that your AI models remain relevant. Okay, so we have basically what we call as lifelong learning model operations, or LLM ops. From a monitoring and maintenance perspective, we also basically do enhancements as part of this to make sure that it remains continuously relevant. And so when you're creating solutions, there are three aspects to this framework. One is you look at productivity, which is not just about cost gains or efficiencies, right? It is about reimagining enterprise functions for higher productivity. And that could mean that you need to look at IT and business operations together. You need to we look at several different lenses, which is software development and assurance. We look at elevating content and knowledge management, and optimizing agent and backend operation, right? From a growth perspective, it's about identifying use cases to boost revenues and customer adoption. Okay, so this is across sales and marketing, where you look at targeted campaigns, how you can run that using AI. You look at improving customer operations and excellence through personalization, and optimizing supply chain operations, as well as industry-specific solutions. Uh, the the bigger or the most important aspect that we also look at is the big bets, that what we call as big bets, which is basically around defining newer business models using AI and Gen AI, right? And there's a couple of things that we have done there. One is around personalized financial advisory. We've done protocol authoring, real-time cross-lingual conversations, improving global communications, and multimodal avatar-based interactions. So that's the framework. Okay, we are a services organization. We work with established and emerging partners across the AI ecosystem, and we continuously are looking at the newer partners. Right, we have strategic partners, we have data and AI partners, we have Gen AI partners, conversational AI partners, vertical focused partners like Guidewire, Backbase in the digital banking space, and we have next level partners like Adobe in the content and commerce space. Right. I will not go into details of these use cases short on time, but I encourage you to talk to us. I have colleagues here who are experts in Amaze, colleagues here who are experts in AI, Gen AI, right? Any queries, come and talk to us. If you have any ideas that you want to discuss further, come and talk to us. But the primary point here is you look at any industry. Hexaware has 6 verticals. That is why you see it across 6 different verticals. But any industry, there are solutions that are out there that we have worked on, right, which impact the different parameters that we talked about, the productivity, growth, or big bets.
You have 1 more minute, please.
Sure. Right. Again, a list of other impactful solutions. There are a couple of things that I just wanted to highlight is around bond reco, which is basically gauging the safety of ERISA bonds using Gen AI and instant loan audit. These are basically case studies which was a win at Microsoft AI Solutions Foundry. Okay, with this, I will not go into any of these details. So primarily, that's the end of my presentation. But I wanted to thank all the participants here. Sincere gratitude to all of you. You've been very patient, waited long enough for this session, and it's wonderful to see you here. Right, and I would encourage you to explore basically how cloud and AI can add value to your organization. As I said, please reach out to us. We are here to talk further. I know 10 minutes too less. I would like to talk more about it. Please, with that, thank you once again. Have a wonderful day.
Thank you. And as a title sponsor, we must give them some work. I have one question for you. The India Data Act is actually much more difficult than GPDR for AI ML. Do you have any idea? Do you have any service around that?
Right. So as a services organization, we work with hyperscalers. Okay. So hyperscalers now have data centers in India across different locations. They've built redundancies, right? But as far as the act is concerned, we do provide services around consulting, which is basically around compliance, right?
Yeah, but let me explain. You cannot get consent from users who are driving e-bikes, etc., for analytics at a dashboard level. So it's very difficult to get individual consumers to agree for AI ML. So is there a generic industry solution that you guys are working on?
Yes, we are. So basically, our solutions, although we do not have any, let me accept that fact, right, for now. But the solution encompasses quite a few things, which is one is around data itself. How do clean data? How do you de-identification of data? That's where you can use AI itself to do de-identification of data, right? And it's also important that people get trained about this. So we do provide training services as well around this. We work holistically with our clients around compliance, data governance, right? So that is in short.
Thanks.
Thank you.
Ayyo. Can you get her slides up? Amazon? Her slides.
Am I audible? Am I audible enough? I'll just test the clicker once. This yellow. You turned it off. Energy efficient. It went out of charge. Okay. I think this is jumbled up a little bit, but thank you all for giving me this opportunity to present on stage with this fraternity. Okay. So, generative AI. I'm sure by now all of you are super bored with that term, but we are all taken by a storm of generative AI, and I've learned so much since yesterday about how different businesses, including startups or enterprises, how they're all gearing up to operationalize generative AI. And even my friend Gourishanker talked about how they are planning to operationalize generative AI, right? That's also very much in their plans, and they are one of our partners as well. They are very, very important to scaling our generative AI agenda as well. So thank you for that, Gourishanker. And your Amaze platform was amazing, actually. So the question in front of all of us, right? So businesses of all shapes and sizes are getting started. But the question is this just hype or is this real? And is it even ready for mass adoption, or is it more like a science project? Right, so these are the critical questions in front of all of us, in front of me as well. So again, my name is Madhuri Susarla. I lead the Partner Solutions Architecture for India for AWS. So I work with a number of others like Hexaware, Accenture, TCS, Deloitte. So we are being stormed by the amount of generative interest coming from all of these partners as well. So we need to take a step back and even ask some of these critical questions like, how much does it really cost to operationalize it, right? And how do we even address some of the privacy, security kind of concerns? And then how do we take it forward and make it like really game-changing experience for our businesses, our customers, and even ourselves, right? For our own employee productivity enhancements. So I think everybody here is very, very familiar with what generative AI is and how it is different from whatever we are familiar with so far. Basically, it is a set of very large models that are pre-trained with internet scale data. They're also called foundational models, and they can be customizable, right? With very little data. You don't need to do it the traditional way where we had to spend months and months just training our model. The generative AI foundational models can be trained very easily, even with as much as 20 terabytes, right? So that is why, that's one of the reasons why it's very, very important. And there are several pertinent use cases. I think you all are all too familiar with all of this. So I will probably skip all of this. But since the use cases are so pertinent, right? It's more than here and now kind of a problem for all of us. And in order for us to be good corporate citizens, right? Be responsible. How do we productionize the generative AI in a responsible way? And what does cloud platforms like AWS have to offer to help you get there, help you make your generative AI sustainable or energy efficient and even economical, right? So the tenets that we use at AWS are, first of all, align your generative AI to your sustainability goals. Right? Whatever choice that you make will have to have your overarching sustainability goal interleaved into it. And why is that? It is because the machine learning function itself needs massive amounts of compute power. Everybody knows that. And in addition to that, generative AI more energy utilizing than the regular CPUs. Okay? And to give you a sense for exactly what kind of carbon intensity a single 1 trillion LLM can create, okay, to give you a sense of that, if you have to train this 1 trillion LLM, it will create 300 tons of CO2, okay, if you have to train it once. And I don't think we are still able to wrap our head around what that means, right? So an average person creates 5 tons of CO2 in a year, okay? And I'm excluding North American person, okay? But everybody else creates roughly 5 tons. But once training 1 trillion parameter scale model will cost 300, okay? So now you get a sense for the kind of problem that we are facing. And that is why these tenets are important. So align it, whatever generative AI approach that you choose, make trade-offs so that you align to your sustainability goal. And then use energy that has a low carbon intensity. Okay? What do we mean by that? So I think cloud is a natural choice. Everybody here agrees, right? Cloud is a natural choice for running machine learning in general, and the same applies to generative AI as well. Agree, disagree? Any show of hands? Is that for agree, Shalini? Yes. So why is it a natural choice? Because it is elastic. Cloud is elastic, which enables pay as you go. And cloud is also giving you cost advantages because of economies of scale, right? Cloud like AWS has millions of customers, so that is natural choice. But more than that, there's another important factor to consider here. Many of the cloud providers have their own sustainability agenda, and if you take AWS, they are the founders of the climate pledge. What that means is by 2040, you have to be net carbon zero. All Amazon businesses, okay? So that is a major driving force. Similarly, we also are in the process of making all our operations backed by 100% renewable energy, okay? And already 90% we are there, okay? So, and then there is also a water positive agenda. So what I'm coming to is, just by running your workload on AWS, kind of a cloud platform, will already help you inherit those properties for making yourself more sustainable, more energy efficient, more responsible corporate citizen. Okay, so that is another thing I want to allude to. And already about 19 AWS regions are 100% renewable energy compliant. Okay, so you can choose to put your workload in any of those regions if your regulatory and legal, rules allow for that, and minimize the data transfer. Okay, and also run your workloads close to your customer. So all of this actually will lead to incredible gains in terms of energy efficiencies. Okay. The other thing which I want to call out is use managed services. When I say managed services, it is services like Amazon SageMaker, Amazon Bedrock. What is the benefit of using these managed services? The benefit is, when you use this, for example, Bedrock example, right? What is Bedrock? It is our serverless, fully managed service, which gives you access to a variety of proven foundational models from different providers. Okay? And when I say serverless managed, what that means is most of the heavy lifting is already taken away from you, right? In terms of patching your server, making it energy efficient, making sure that the server is optimally utilized. You don't have to worry about any of that when you use these managed services, which is why we always advocate these services. And the same goes with Amazon SageMaker, which is again giving you an integrated platform for building, training, and deploying your machine learning workloads. You have debuggers, you have profilers, you have ways to measure your model drift. So all of this is ultimately leading to you running your generative AI or even regular machine learning workloads very efficient. So lastly, and I think this is the most important factor, is choose the right customization strategy. Okay? Oh, I think sorry. All right, okay. So what do we mean by model customization? There are several ways in which you can customize the base model itself, right? And it is not always required for you to retrain or even for fine-tune, right? So I've tried to summarize the energy efficiency, or in other words, environment impact of different customization strategies, starting from prompt engineering all the way to full fine-tuning and training from the scratch, okay? And the top one is prompt engineering, which is having the least impact on the environment, okay? So your model customization strategy will have to follow this. You can use this as a guideline to understand which is the best for you. It is not always necessary to do tuning, even fine-tuning. There are many other ways to do that, specifically for the generative AI workloads. So this is just a picture that will give you understanding of the entire AWS set of offerings that will help you productionize your generative AI workloads. But what will be of important is basically 3 tiers, where we're talking about the bottom tier addressing people, businesses that want to do everything from scratch. The middle tier is where you have managed services, people who want to kind of quickly leverage what the cloud offers and do it in an efficient manner, even though they may not have adequate level of machine learning expertise. And
Madhuri, 2 more minutes, please.
Okay. So, and the top layer is where we have the generative AI business applications. Okay. So these are ready-made business applications for you. These are something that you can readily use. You don't have to use any kind of model customization strategy. You don't have to run GPUs. You don't have to worry about energy efficiency, nothing. You just use them and pay as you go. Yeah, I got this jumbled up. Okay, so in addition to prompt engineering, we also have many other ways that you can do model customization, right? You have something called PEFT, which is partial tuning of your parameters, which can still give you the same kind of performance capabilities for your model, just like how a full tuning can give you. But if you do decide to go with a if you do decide to go with a situation where you want to train the model from scratch, that is where the bottom tier will be useful for you, because there we offer custom silicon, okay, which is purpose built for both training as well as for inference. So, that was even mentioned by Dibyendu, AWS Trainium, which is purpose-built for your training workloads, and AWS Inferentia, which is purpose-built for your inference, right? And the reason purpose building is important is because they are tailor-made for training as well as inference. Given the massive needs of generative AI, it is super important for you to adopt some of these custom silicon solutions to automatically maximize on your cost efficiencies. With that, I take leave. Thank you all for your patience.
Thank you. 2 questions. We have been well behaved managing time. So I have a troublesome question and an easy question. And this comes from the fact that I am the 400th guy who signed the first 1,000 on Pause LI. You may not be aware, but Gen AI query, if 2 million users run it, forget the 1 billion that run normal queries, you need 100 megawatt power. A full atomic power plant is needed, and you need 500 tons of water to cool. So 2 questions. Whether Inferentia, Graviton, does it less energy, less power? Whether you can publicly say something. And second, can developers actually use those chips quickly? Those 2.
Yeah. So to answer your first question, yes. So our custom silicon is already tested vis-a-vis non-custom silicon kind of a situation. I'm not saying that it will save X amount of water or it will reduce Y amount of carbon footprint. So I am not privy to those numbers at all. But as I called out, Arvind, we are ourselves going to be water positive by 2030. Which means we have to give more water than we consume by that date. If that gives you any
Thank you. Thank you.
Satisfaction in terms of...
Thank you.
Okay.
We have some time, so we can take some questions. Please feel free. All silent, sleepy? All right. Looks like we have done a good job. All right. Thank you then. All right. You're keeping me busy. All right. Question, please. No observations.
Yeah,
Questions.
my question to the Intel person. You had deployed Intel in 5G in core network in IIT Bombay, where SDN and NFV
Excuse me. This is an AI session, not a 5G session.
No, AI concepts is implemented. So can you throw light on that?
I don't think I know.
He is a compiler guy. He's not a 5G guy.
No, I'm talking
I
about
don't know.
AI compilers are used in the SDN and NFV concept in the Intel server that is supplied by Intel.
You know,
Googlier.
am I audible?
You're-
So if you look at from the current generation of the CPU, forget about the GPU and AI, the AI accelerators where obviously the AI compilers are in effect. Even on the CPU, which is the Sapphire Rapids, as I showed you, we have actually the first general purpose, thing, which is not an accelerator or a GPU, where we have the AI capability built in the hardware through the TMUL instruction, and the vector instruction already there. Intel has been supporting special inferencing instructions called the VNNI set from way back, Skylake and onwards. So if you want to utilize, in some cases you have to rewrite your software in a way to utilize those instructions. But in general, the hardware is absolutely capable, and if the software is taking, even on the 5G line or whatever other thing, you should be able to get that. Okay.
Thank you.
Thank you.
So just to use it, in Python, if you say A at B, there is an at command for vector that gets into the hardware level vector operation. Next question.
So my question is with Hexaware. What is your USP over a big player like Amazon, Google, Microsoft? In other words, I being a customer, why should I will go with you when it comes to AI, cloud computing and AI? Yes.
So we are not competing with any of these, right? We are service providers. We work with all of these. We work with the capabilities that they develop. Okay, we are in the business of basically using that to create value for our customers. Okay, if that answers your questions, because I don't see them as competitors.
Just to give an example, SAP Cloud is not on its cloud server. It's anyway AWS or someone else.
Yeah, so we are the implementation partners for SAP Cloud, right? In that sense, so we will be utilizing all these new technologies that are getting developed to basically help. As Professor Nitin said prior to this, right? We are in the business of solving real problems using these tools.
So the counter is timing down, and we need to close one last question. Before he shuts us off. Go ahead, sir.
Thank you, the panel, for this incredible insight into Gen AI and applications. So my question is to you, Gourishanker sir. So you mentioned about the 3 waves of cloud computing, IaaS, PaaS, and SaaS. So in the Gen AI space, what are the enterprise SaaS offerings that are in demand from companies? Of course, we can appreciate the impact in the consumer space, but what are the enterprise SaaS demands that are coming from the companies?
Are we looking for some startup ideas from this? Nobody would mind that. If you have some insights, enterprises need problem solved, startups are always hungry.
Yeah, so it's too early in the stage to have those insights. We are working with several large customers, and are exploring these options, right? But the way it is poised right now is that this will definitely become the game changer. Every organization is looking at, okay.
We need to really cut off. We are running out of time. Thanks a lot. It's too early. Lots of things can happen.
Wonderful. Thank you so much, Arvind. And thank you so much, all our esteemed panelists. Arvind we have to specially applaud for Arvind and the entire panel for being precisely on time. This is a special kind of a thanks as well. But this was wonderful. We've had a lot of rich insights coming in from how the cloud is going to be, transformative for the adoption of AI. You brought in a bunch of solutions that all of you are working on. That helps us build some sense of what we can do potentially as well. And thank you, Arvind, for moderating this beautifully. I really, really appreciate this. So with this, I would like to now, hand over a small token of appreciation. Praveen, where is Praveen? Yes. So Praveen from the Pivot marketing team would be handing over the token of appreciation. I would like the audience to please applaud while this happens.